Welcome to my YouTube channel Mediguide Lectures, learning with artworks like drawing and calligraphy. In this video, we will discuss about the adrenergic transmission. Neurotransmission refers to the transmission of nerve impulse from one neuron to another neuron or to an effector site by releasing chemical substances called neurotransmitters. When the neurotransmitter, noradrenaline or norepinephrine, adrenaline or epinephrine, and dopamine are used for transmitting impulse, then this type of neurotransmission is called adrenergic transmission. These three neurotransmitters are called catecholamines. This type of neurotransmission occurs in the CNS and in the sympathetic nervous system. But in here, we will mainly focus on the noradrenergic neurotransmission. Generally, the noradrenergic neurotransmission involves several steps. For this, here I am drawing the presynaptic axon terminal from which the norepinephrine are released and postsynaptic site on which adrenergic receptors are present, and this is synaptic cleft through which the neurotransmitters are diffused and bind to postsynaptic receptors. Here, the first step in the noradrenergic neurotransmission is the synthesis of noradrenaline or norepinephrine. First of all, tyrosine is an amino acid which is transported into the cytoplasm or the exoplasm of adrenergic neuron. Then this tyrosine is hydroxylated by tyrosine hydroxylase to dihydrophenylalanine or DOPA phosphate. In the following step, the DOPA is decarboxylated by enzyme dopamine decarboxylase to form dopamine in the exoplasm of adrenergic neuron. Then we have the second step, which is the storage of noradrenaline in vesicles. The dopamine is transported into synaptic vesicles with the help of an amine transporter system called vesicular monoamine transporter. After this, dopamine is then hydroxylated to form norepinephrine by the enzyme dopamine beta hydroxylase here. The next step is the release of norepinephrine. The arrival of action potential at the presynaptic nerve terminal causes the opening of voltage-gated calcium channels. High calcium level in the exoplasm interact with the vesicular membrane protein, which causes the fusion of the vesicles membrane with the presynaptic membrane, and at last the exocytotic expulsion of norepinephrine occurs in the synaptic cleft. Now the next step is the binding of norepinephrine to its receptors. The released norepinephrine diffuses across the synaptic cleft and binds to either postsynaptic adrenergic receptors on effector organs and causes a biological response through the formation of intracellular second messengers like CMP, DEG, and IP3. Or this released norepinephrine binds to presynaptic adrenergic receptors on the same neuroterminal and inhibit further release of the neurotransmitters into the synaptic cleft. And the last step is the removal of norepinephrine. Norepinephrine actions terminated either by simple diffusion of norepinephrine away from the receptor site to blood, followed by metabolism in plasma or liver by enzymes like catechol-O-methyltransferase, and metabolites are excreted in urine. But here, most of the norepinephrine released are taken back into the same neuroterminal by a transporter called norepinephrine transporter, where norepinephrine is stored back in the synaptic vesicle for next release, or it may be oxidized by neuronal mitochondrial enzyme monoamine oxidase and metabolites excreted in urine. The reuptake is the main pathway of determination of action of norepinephrine, and about 75% of the noradrenaline released by sympathetic neurons are recaptured and repackaged into vesicles. And with this, thanks for watching. Do like and share this video and support us by subscribing to our channel.